Alright, hey guys, how's it going? I just wanted to quickly go through the idea behind factorising. This is actually a Year 9 standard, but we do test it a little bit at Year 8, just the general idea. So if it's a bit beyond you, don't stress too much, but hopefully it makes sense. So the idea being, if you have an expression like this, I have 22x minus 8y, that perhaps there is a simpler way of writing this. And when I say simpler, I mean using smaller numbers. So yeah, let's break it down, and then I'll explain what this sort of means. So what I want to do is I want to look for the highest common factor of these two values, right? So firstly, let's look at 22, and we'll deal with the letters later, but let's look at 22, right? The numbers that multiply to make 22 are 1 and 22, and you also have 2 and 11, and that's it, right? The number 8 has, you have 1, 8, 2, and 4, and that's all, right? So of these, the highest common factor that they both have in common is 2, right? So what I can actually do is I can rewrite this with a 2 out the front, right? And then inside of these brackets, I'm going to divide both of these by 2. So I end up getting 22 divided by 2 is 11. Don't forget the x is still there, right? Minus 8 divided by 2 is 4. Don't forget the y is still there, okay? And you might be like, how is this simpler than that first one? Well, think of it this way. If you were told that you had to count 22 of something and 8 of another thing, right? And figure out, how much the whole thing's going to cost, for example. This is saying an easy way to do it would be just to count 11 of one thing and 4 of the other, and then just double that price, and it wouldn't matter, right? So it's trying to limit the amount of limit the amount of calculations that need to be done, all right? And that's a very simple sort of explanation. It's obviously a lot more detailed than that, but I'm hoping that at least you can sort of relate to that idea. But what about the letters, right? Because the letters is where things start to get tricky. So let's go through a couple more examples, and I'll show you how to do some that you have to take letters out to. So this first one, there's only one lot of letters, so that's okay. So the highest common factors of 6 and 9, we have 1, 2, 3, and 6, right? I'm just writing them in numerical order. So 1 times 6, 2 times 3. 9 has 1, 3, we already have 3 and 9, right? So just 1, 3, and 9, because it's 3 times 3. Okay, so the highest common factor in both of these is 3, meaning I divide both of these by 3, right? And I can put a 3 outside in brackets. So 6f divided by 3 is 2f, minus 9 divided by 3 is 3, right? So that's the simplest way to do that, but this is where it's going to get a bit more interesting. So let's do it the exact same way. We're looking at 7 and 14, right? And this is 1, 14, 2, and 7, right? So in this case, the highest common factor of both of these numbers is 7. So good. So I can take a 7 out the front. The thing is, though, as you can see, there are also common letters, right? So there's letters that are shared between both of these, because essentially we're saying that, I'm just going to draw this up here, 7e squared is 7 times e times e, and 14ef is 14 times e times f, right? So there's actually something more in common than just the number 7 between both of these values. There's a common e, right? So because there's an e in both of these, we can actually take the e outside in the bracket as well. right? Like that. So what is 7e squared divided by e? Well, it's just 7 times e divided by 7 times e. It cancels itself out. And it just gets left with a single e. All right? If you're not sure how that works out, if it's 7 times e divided by 7 times e, the 7's cancel, the e's cancel, and you're left with just an e, right? E plus whatever 14ef divided by 7e is. Well, again, 14 divided by 7 gives you 2. The e's will cancel each other out, and you get left with an f. So that's how you simplify one of those more complicated ones. All right, now let's try another hard one and give it a go. So common factors of 3 and 5. Well, there's 1 and 3, and there's 1 and 5, right? So in this instance, the highest common factor is 1, right? And that means that we don't do anything to the numbers at all, really. There's no point. You can take a 1 outside, but dividing both of these by 1 isn't going to do anything. So we have to look at the letters now. Well, we have PQ and P squared Q squared, which is the equivalent of looking at what's common between P times Q and P times Q times Q. Right? There's AP and AQ in common, right? So we can divide both of these by PQ, and that will give us, outside in the brackets, PQ. We have a 3 minus 5. Now, if it's P squared divided by P, that leaves just 1P. If it's Q squared divided by Q, that just leaves 1Q. So that is our simplified version of that. So it's probably one of the harder examples that I could find. But I hope that makes sense. Yeah, thanks guys. Enjoy the rest of your day.